and welcome to SciLux, the podcast where we talk about scientific developments and technological changes in Luxembourg. And in today's show, we are not going to interview anybody. It's going to be the old format, so I'll tell you a little bit more about different developments in Luxembourg, what is happening right now, what was happening, because it's been quite a few months that I haven't really talked in general about different projects, different studies, articles, and so on and so forth. So I have definitely a lot to share with you. Originally, I was planning to have a summary of last year's developments, but unfortunately, I didn't really manage to record it early enough. And I think summarizing in the middle or actually end of February is a little bit too late. But of course, if you're interested in a summary, you can always see there was something posted on the Twitter account about that. And I will also remind you about a few different things that have been happening in Luxembourg. But today we will be focusing a little bit about stuff that you could read about and hear about last year, but also a little bit this year from different institutions. We are going to talk about brains sent to space, and not only, also here, and the research and treatments of different diseases related to our brains. And also another topic that will be a bit prevalent in our podcast today is AI and machine learning, and how the scientists actually apply different solutions to their research. But first, as usual, it's time for the pub quiz. In today's pub quiz, we are actually coming back to something we already discussed quite a few months ago. So the HPCs, the high performance computers, or supercomputers as we like to call them. And my question is, how many HPCs, how many supercomputers are there at the University of Luxembourg? I hope you know the answer already, and if not, I'm going to reveal it at the end of the podcast. And now on today's subjects, and the first one is going to be something that I haven't mentioned in the introduction to this podcast. I want to tell you a little bit more about probiotics and the ideas that the scientists in Luxembourg have had and their application. So as you probably recall, probiotics, we normally discuss them when we talk about our gut flora and the fact they are very good for that. So we discuss more kind of like an inner body working, but here we are going to talk about outside. So the scientists, at least the Luxembourg Institute for Science and Technology, have decided to have a little experiment and try to see whether the probiotics can also be good for built environments. So whether they can actually help us remove and fight the formation of pathogenic microbes, not in the human body, but as I said, like on kitchen surfaces or on a medical room. So there is a special group, at least, partnered with the Probiotic Group Luxembourg. And in collaboration with LCSB, they decided to look at the possibility to find certain bacterial strains. They actually discovered about 50, more than 50, that should be able to degrade organic matter and also fight other pathogens in built environments. As we know, still some cleaning products nowadays can contain toxic chemicals. And we would like to find a more environmental friendly, better for our health as well, products that could be used. So they started this cooperation with other institutes and also this Probiotic Group Luxembourg, and they are trying to develop a certain, let's say, recipe book, as they called it, to help this group produce cleaning products. The plan is to make it vegan compatible even, if not at least certified in from an ecological standpoint, as it was explained by Henri-Michel Cauchy, who is the researcher in charge of the project. First of all, as I said, they identified the candidates, and now what they want to do is look at the genome, because just like humans, bacteria have genes coding for a particular function, and they want to look at which bacteria have these genes that help produce interesting molecules. They are called bacteriocins, so the proteins capable of inhibiting the growth or even destroying pathogenic bacteria. So this is first this kind of identification. Then, once they select these, they will test them on various type of hard surfaces, stainless steel, for example. And then the third one, the final stage of the project, is to produce the selected candidates at a pre-industrial scale and hopefully introduce some better and more ecological cleaning products. 5 students from the University of Luxembourg will send mini brains to the International Space Station. And what they will do is carry out some research experiments under microgravity conditions. In this particular situation, this is the project called BRAINS, as I mentioned before, and it stands for Biological Research Using Artificial Intelligence for Neuroscience in Space. It was selected as one of 4 projects by the jury of the Überflieger 2 competition, which was organized by the Luxembourg Space Agency, as well as the German Space Agency, Deutsche Physikalische Gesellschaft, and URI GmbH. The students who will send these mini brains, these 3D cell culture systems that we're talking about, are Elisa Zuccoli, a PhD candidate from LCSB, as well as fellow PhD candidate José Ignacio Delgado Centeno, and 3 master degree students, Daniela Vega Gutierrez from the Master Program of Integrated Systems Biology, Aileen Chong Castro and Lina Maria Amaya Meilla from the Interdisciplinary Space Master. So what they are planning to do is to look at how these 3D cell cultures will grow in space. They will be able to see it in the microgravity, which provides a very good starting point and observation point because it mimics the free-floating state during embryonic development. What they want to see is whether these organoids will grow faster, what will happen with them, will they be larger, maybe less densely packed. And then further from this, they hope to have results that can influence the pharma industry, the regenerative medicine, and many other applications. Another point that is worth mentioning is that they will also use artificial intelligence, this time for image analysis, to compare the findings with the current experiments performed on the ground. Good news for the students, not only their project was chosen, they will also be able to participate to witness the launch of the rocket that will carry the experiment to ISS. Most likely it will happen in the 4th quarter of 2022 or 1st quarter of 2023. And as promised, another piece of news about brains. This time we're talking about brain tumor, a very aggressive, highly aggressive type of cancer, which is called glioblastoma, GBM, that develops in the brain. And unfortunately, we're talking about an average survival time of just 12 to 18 months, despite a range of different treatments like surgery or chemotherapy. The problem is that with the current tools and the current developments in the field, it is basically impossible to stop the tumors from growing back. So even if the treatment is successful, you have to start anew. Here in this particular research, we're talking about the findings of the team led by Dr. Anna Gołębieska, the group leader of the Norlux Neuro-Oncology Laboratory at the LIH, Luxembourg Institute of Health. And what the scientists did, they reviewed all the available existing literature on this problem, the GBM, and they came up with this conclusion that what is definitely needed right now from the recent findings and recent discussions is to start looking at the tumor in a different way, at the fact that it manages to disguise itself, is able to transform, and rather than target the single entities, we need to target the dynamic states. So what is to follow from this conclusion is that, of course, further studies are needed, and we need to look for drivers of plasticity and some treatment escape. So in a way, first focus on the dynamic part and then hopefully get to a possibility where the foe or the enemy, as the scientists call it, is unarmed and we can really target it well and find certain treatments that will result in success and different further developments, hopefully better treatment of other aggressive tumors. I'm definitely going to tell you more about it because this is very important research in Luxembourg. Hopefully one day I can also host Dr. Anna Gołębiewska. Before I manage to do that, I will post in the show notes a podcast where she is talking a little bit about her research. So stay tuned, check it out. And on the subject of AI, now a little bit different application, AI and art. So I'm sure you've already heard all these discussions on, Pushkin, AI writing like Pushkin or any other famous writers. We've also had this idea that artificial intelligence can help us, maybe augment the creative process, can paint, help us sketch something and so on and so forth. But here we are not talking about that. We're talking about a different application. And what is it? So what I wanted to tell you about is more AI and art market. Here we are focusing on an analysis done by a group of researchers, part of which was Roman Kroesl, professor at the Department of Finance at the University of Luxembourg. And we also have researchers from Paris, from Berkeley. They published all these findings in the paper called Biased Auctioneers. And what did they find out? They actually tried to analyze painting auctions. They analyzed 1.2 million painting auctions from years 2008 to 2014. They analyzed both visual characteristics and non-visual ones, and they were trying to apply a neural network algorithm that was mimicking the process of human appraisals. And this algorithm was trying to generate price predictions for art at auction. So that's the main idea. And then they collected this data and they were basing themselves on this data. The data was artist, medium, auction house, and so on and so forth. And then they were trying to have some pre-sale estimates, the buy-in price, so the minimum price at which the work will be sold, and also the final auction price. And this was all related to the year 2015. And then they compared it with real data. What was interesting is that they were not trying to say, okay, AI is better, let's get rid of the auctioneers. No, they were just trying to say, maybe we can use this. Maybe we can sometimes help with some bias, with some situations where maybe there is some man-made market inefficiency. Because sometimes, the valuations can be pessimistic or optimistic. What they found out is that still the auctioneers were more accurate, and basically the main reason was that they just had more data, more knowledge. They knew the provenance, the condition, maybe they knew the historical context, so they were way better in evaluating the works of art. But still, at the same time, it means that we are getting somewhere there, and we can actually use this as an opportunity to help, to support certain valuations. And of course, this was only the art world, but it can be applied to many other real assets, which rely heavily on human appraisers. We can talk about the real estate market. That definitely could benefit from the research. So we have to remember, this is not about replacing anybody, but rather helping, augmenting the abilities. And talking of augmenting computers and supercomputers and everything else, machine learning as well, we've come to the moment when I would like to reveal the answer to the question. So the question was, how many supercomputers are there at the University of Luxembourg? And currently, there are 2 supercomputers. So we're talking about Iris and Ion. There have been some other ones before, but these are the 2 ones that researchers at the University of Luxembourg can use. They have a computing capacity of 2.76 petaflops. So if you compare it with Melusina, I told you about, Melusina is 10 petaflops, so they are not as powerful. However, still very, very helpful for all the computations, all the research that is done at the University of Luxembourg. And one of the research I wanted to tell you about after revealing the answer to this question is a research done by Niccolò Gentile. He's a doctoral researcher in behavioral sciences and individual well-being. And what he uses HPC for is to do some computational modeling and forecasting in the field of psychology. So what do I mean? It all bases itself on the idea that well-being can be measured by life satisfaction, happiness, psychological functioning, demographics, socioeconomic factors, biological factors, psychological factors, environmental, many different factors. So a lot of data that is being collected. And using that data, the scientists are trying to model individuals using the set of characteristics. And Gentile works on data science and the economics of well-being. There's the DSE Well project. It's a project funded by the university's Institute for Advanced Studies, and it brings together machine learning approaches, physics-inspired descriptors, and the economics of well-being to address questions that are related to that, to help predict well-being of individuals in a data-driven manner, and also maybe to predict certain changes like depression, thanks to that. So it's not only about saying, okay, you are well and you're not, but also being able to predict something in the future. Together with a team, Niccolò Gentile, under the supervision of Professors Conchita D'Ambrosio and Alexandr Tkachenko, works on data sets. You might ask, okay, where do you collect such amazing number of data points? So we are talking here about the 1970 British cohort study, the so-called BCS, and that's when the lives of around 17,000 people born in England, Scotland and Wales were monitored. It was in a single week of 1970. And then also the German socioeconomic panels, the so-called SOEP, and that was a very long survey of approximately 11,000 private households in the Federal Republic of Germany. Actually, it's still current now from 1984 until today. And also the lands of former Eastern Germany from 1990 until today. So thanks to that, thanks to all the data collected both in Great Britain and Germany, we can now work on this special modeling, the special data set using HPC at the University of Luxembourg. And the results, it seems, are very, very promising thanks to the number of data points, as I mentioned. The scientists say that yes, we can say that the marital status and the emotional and physical health continue to be the most important predictors of life satisfaction, but they're also saying that gender is not important. So it doesn't matter if you're a woman or a man, you're equally happy or unhappy. That's one of the details. And also, one of the improvements about this model is that they are really more able to predict if someone is at risk of depression. So once again, one important factor. I just wonder whether data only from Germany and Great Britain can help us, because, there are nations that are actually infamous for having higher depression rates or suicides as well. So I guess it would be great to collect data from these places as well before we can really talk about the model. But that's just my side note, let's say. So anyway, I hope that you enjoyed the show today, because this is the end. Yes, so we haven't talked to any scientists, but still about 20 minutes of different important topics. I wanted to give you also some interesting piece of news, namely, Luxembourg has become the new headquarters of the International Federation for Public History. So congratulations to all the people at C2DH, especially Professor Thomas Covin, who was a guest in our podcast, because this is really good news. We will be the center for public history, hopefully. And also this means probably a lot of new interesting projects in that field. I also wanted to mention and congratulate the museum in Luxembourg. I guess you know which museum I'm talking about. Once in a while I come back to the Museum of Natural History in Luxembourg. Why? Because last year was very fruitful for them. They've done a lot of interesting projects that I've talked about or I haven't had a chance to mention. I wanted to remind you about inaturalist.lu. Please visit this website. This is an amazing place to collect and discuss all the different observations and also work on the subject of biodiversity in Luxembourg. And we've had also other things happening, all the exhibitions. I hope you've visited the Lost Ocean exhibition that is still on. If you haven't, go, because I think it's one of the best so far that I've had a chance to see. I haven't seen a lot, but I really enjoyed that one. So yes, once again, a few different congratulations to finish. And now I just wanted to tell you that I am always looking forward to anybody who wants to participate, who wants to be interviewed, to comment, to just say hello from any place in the world where you're listening to this podcast. Please follow us, subscribe, write on Twitter, LinkedIn, Facebook, or any other way. I hope you enjoyed the show. This was Silax, and my name is Hanna Siemaszko.